So let us start. So we begin this proposition. Proposition. Let A to B, F and B to C, G be morphisms. Be morphisms. Then these are the things. If F is an extremal monomorphism, if F is an extremal monomorphism, and G is a regular monomorphism, and G is a regular monomorphism, then G composition F is an extremal monomorphism. Then G composition F is an extremal monomorphism. Secondly, if G composition F, if G composition F is an extremal monomorphism, is an extremal monomorphism, then F is an extremal monomorphism. Then F is an extremal monomorphism. And last, third condition, if G composition F is a regular monomorphism, if G composition F is a regular monomorphism, and G is a monomorphism, G is simply a monomorphism, G is a monomorphism, then F is a regular monomorphism. Then F is a regular monomorphism. So these things we have to see. Let us see one by one. Let G be a regular monomorphism. Okay. So it means G is an equalizer of some pair of morphisms R and G. So let G be an equalizer of the morphisms R and S, of R and S. So G is actually from B to C. This is G, and C to D have R and S respectively. So since it is an equalizer, so it means it has to satisfy these two conditions. First condition is R composition G is S composition G, and if you have some object here, say B dash, and from here to here you have say H, such that so if R composition H is equal to S composition H, then there exists a unique from here to here, say K. Then there exists a unique morphism K. There exists a unique K from B dash to B, such that uh, G composition K is H, such that G composition K is H. So this is our given thing. So you have this G regular monomorphism. Now F is given as an extremal monomorphism. So our job is to show that G composition F is an extremal monomorphism. So let G composition F equals H composition E, where E is an epimorphism. E is an epimorphism. So we just need to show that E is an isomorphism. Okay. then R composition, if you take, because we have just seen that R composition H is same as sorry, this R composition G is same as S composition G, so we shall use this condition. Now I take R composition H, then R composition H composition E. Okay, this is R composition G composition F, and R composition G is S composition G, so it is S composition G composition F. Okay, and G composition F is again H composition E, so it is S composition H composition E. And E is an epimorphism, so it is left cancelable. So since E is EP, it implies that R composition H is S composition H. Okay, so therefore we have just seen that there exists a unique morphism K such that, so thus H is equal to G composition K. H is equal to G composition K for some unique morphism K, which is from B dash to B, where K from B dash to B is unique. Now hence G composition K composition E So it is H composition E. H composition E. So H composition E. And H composition E is G composition F. G composition F. Okay. So you have G composition F equals, you call this morphism say as L. G composition K, you call it L. L composition, L composition E, L composition E. So now you have G composition F equals L composition E, where E is an epimorphism, but G is given as regular monomorphism. Okay, so what does it mean then? So you have G composition K composition E, which is equal to G composition F, and since G being a regular monomorphism is a monomorphism, and since G being a regular mono is a mono, so what does it mean? It means K composition E, so G is actually cancelable from right, so this means K composition E is F. Okay, no, just don't call, don't introduce this step, so simply see this one. So G composition K composition E is G composition F, and G is mono, so K composition E must be F. Okay, and F is now F is uh, extremal. F is extremal mono, extremal monomorphism. So it just implies that E must be an isomorphism. E must be an isomorphism. So we are done. So we have shown that if G composition F is H composition E, where E is an epimorphism, then E is an isomorphism. This is what we have shown, and hence it shows that G composition F is an extremal monomorphism. Hence G composition F is an extremal monomorphism. So which proves the first part of this proposition. Now second part, in the second part, if G composition F is extremal monomorphism, we have to show that F is an extremal monomorphism. And this is a bit straightforward. Second part. So since G composition F is extremal monomorphism, extremal monomorphism, so this means thus G composition F equals H composition E, where E is EP, implies that E must be an isomorphism. E must be an isomorphism. This is your given. Now we want to show that F is having this property. So for this, let F equals K composition E bar, where E bar is an epimorphism, where E bar is an epimorphism. So we will show that E bar is an isomorphism. But then G composition F, which is G composition K composition E bar. Okay, which is G composition K composition E bar. It is true for every EP. Whenever G composition F is H composition E, where E is EP, then E must be an isomorphism. So here you are getting that G composition F is G composition K composition E bar, and E bar is an EP. So E bar then must be an isomorphism, since so call this condition as, call this whole thing as star. Okay, so from star, so from star, E bar must be an isomorphism. So we are through, we have shown that. So which shows that F is an extremal monomorphism, which shows that F is an extremal monomorphism. So we are through. Now third part, in the third part, if G composition F is regular and monomorphism and G is monomorphism, we have to show that F is a regular monomorphism. So that means F has to be an equalizer of some pair of morphisms. Okay. So third part, let G composition F is regular monomorphism. That means G composition F is an equalizer of some pair of morphisms, say R and S. That is, G composition F is an equalizer of R and S. So you have this, then you have this set of situation. So see this, here you have from A to B your F, B to C you have G, and say C to D, the pair of morphisms which are being equalized by G composition F is R and S. Okay, so the first condition that it satisfies is that R composition G composition F is S composition G composition F, and for any object A dash and a morphism from here to here, say H, so if R composition H is S composition H, then there exists a unique morphism from here to here, so call it K, then H equals K composition G composition F, K composition G composition F, where this K is unique. So K is unique. Okay, so I will just create a small diagram within this diagram. Now from 1, I will show that F is an equalizer of R composition G and S composition G. This is my aim. because I have to show that na F is an extra F is a regular monomorphism, so it has to be an equalizer of some pair of morphisms. So F is from A to B, so I will just take these pair of morphisms. Okay, call it, first one is R composition G, and no, this is S composition G, and you take this here to here. This is R composition G. So I will show that F is an equalizer of these two pair of morphisms. And first condition is satisfied here. So see here, you have this R composition G composition F is S composition G composition F. Okay, so call it 1 dash. So 1 dash, first condition in the definition of equalizer is satisfied. Okay, now suppose you have an other morphism from A. So suppose you have an object here A double dash, and you have morphism from here to here, say H dash, such that, now suppose H dash from A double dash to B, such that R composition G composition H dash is S composition G composition H dash. But this also implies that R composition G composition H dash is S composition G composition H dash. Okay, uh, and so there exists a unique morphism K dash from A double dash to A, because we have seen that R and this F composition G. Uh, just 1 minute. Where are we missing something? No. Just go back. No, we have this condition. No? If R composition H is S composition H, the second thing, then H must be this thing. Okay, so I think we are true. So you have R composition G composition H dash is S composition G composition H dash. So there must exist a unique morphism from here to here. Call it K dash. So this there exists a unique by second condition. Okay, so by 2, you call it by 2, there exists a unique morphism K dash from A double dash to A, such that uh, G composition H dash must be same as G composition H dash must be same as G composition F composition K dash. Okay, but G is monomorphism. But G is mono. It implies that H dash must be F composition K dash. Okay, so you have this small triangle commutes, small triangle commutes. So which shows that F is an equalizer of R composition G and S composition G, and so therefore F is regular monomorphism. So thus F is an equalizer of R composition G and S composition G. So this means F is regular monomorphism. F is regular monomorphism. So we are through. We have proven this. And as a corollary of this proposition, you have that every regular monomorphism is extremal. Okay. Every regular monomorphism is extremal. You can prove this. It is just, it follows from this proposition. Every regular monomorphism is extremal. So a corollary of this theorem, every regular monomorphism is extremal. So I will give the proof for you as an exercise. You apply this proposition and get that every regular monomorphism is extremal. So I think we will stop this lecture. So if you have any questions, you can ask. Any questions, please?
सर क्या वो जो हम दिखा रहे थे ना अभी जो कोडोमेन रिस्ट्रिक्शन वो हर एक मैप के लिए हम कर सकते हैं कोडोमेन रिस्ट्रिक्ट?
मुझे लगता है अगर इंजेक्टिव होगा तो आप कर सकते हैं, है ना? इंजेक्टिव के लिए आप कर सकते हैं, हर के लिए नहीं कर सकते. ठीक है?
यस सर.
You think on that. Any other question?
सर
तो सर वो जो आपने सीआई में वो क्वेश्चन नंबर लास्ट था ना वो
Yes.
इक्वलाइजर पे, सर उसके लिए आपने बोला ना सर फिर मैं देख लूंगा.
क्या था
अब
उसमें?
उसका सर कुछ हुआ?
वो गलत था क्वेश्चन.
वो नहीं सर वो ठीक था एक्चुअली, वो सीआई के लिए नहीं पढ़ना था तो हमने नहीं पढ़ा था.
मैंने बताया था नहीं पढ़ना है.
नहीं सर वो सीआई के लिए नहीं पढ़ना था.
कोई बात नहीं. I will give 1 bonus mark to every student.
थैंक यू सर.
So we will just go to co-equalizers maybe in the next class. Actually, the notion of co-equalizer is just the dual notion of the notion of equalizer. So most of the results which are true for equalizer, in fact all the results which are true for equalizers, you can prove for co-equalizers by the principle of duality. We will see in the next class. Okay. So till then I think, okay, goodbye from my side.